So now let's get to the lesson. Adding and subtracting rational expressions. From the do now, when you add fractions, what's the goal? The goal is to get a common denominator. Do we have a common denominator, Brian? We do. If we have a common denominator, what should we do after that? Add the numerators. Exactly, exactly. So if you remember what we did in the do now, we had 1/5 plus 2/3. So in the do now, we had 3/15 plus 10 over 15. So in the do now, you don't have to write this out. In the do now, when you have a common denominator, your answer is just one fraction and you add the numerators. So it's 3 plus 10 over 15. You all follow that, right? It's 3 plus 10 over 15, which is just 13 over 15. When you're dealing with rational expressions, if you have a common denominator, it's just going to be a plus 11 plus a minus 21 over the common denominator, which is 3a minus 5. So if we have a common denominator, it's just one fraction, and we add the numerators. Does everyone follow? Add the numerators, put it over the denominator, and we'll combine like terms in the numerator. So a plus a is 2a. 11 minus 21 is negative 10. 2a minus 10 over 3a minus 5. This is your final answer. Any questions about this first example here? Now let's move on to the next one. Brian, what's the goal?
Get the same common denominator.
Do we have a common denominator here?
No.
We do not. So we have to manipulate some things. You think you know what we need to do?
Do you square the second one?
If we square this one here,
Yeah.
all right, so if you squared this here, don't write this down. If we square it, this is going to be 36 over x plus 2 times x plus 2 if we squared it. So would it be a common denominator? Wouldn't. But you're on the right track, though. I like how you're thinking. Spencer,
Multiply by 2x.
if we multiply by 2x, this becomes 12x over 2x squared plus 4x. Not it, but I like how you're thinking. I like how you're thinking. Ian,
I mean, if you multiply it by x, you would get like x squared. It would be x squared minus 4.
exactly, and we need it to be the same, right? So you're getting there. Yeah, we're getting there.
Would you do negative 1 to the second?
Say that again.
Wait, never mind.
Never mind.
No.
Come on.
Would it be x minus 2?
Where?
No.
Where?
Multiply x plus 2?
By x minus 2?
Yeah.
Yes, but why?
Because you don't, then the x would go to
You're like right there. X minus 2 is what we need. And here's why we need it though. It's you know why we need x minus 2?
Because it needs to be negative 4 with the common denominator.
Exactly.
Positive 4.
Exactly. Exactly. So x minus 2. So here's the thing. When you're looking for a common denominator when we're dealing with rational expressions, if you don't know where to go, see if you could factor any of the denominators. I'll say that again. If you get stuck, see if it is possible to factor one or all of the denominators. Can you factor one or all of these denominators? Can we factor this denominator on the left? X squared minus 4. Is that factorable? Yes.
There's x minus 2, x plus 2.
Thank you. So the one on the left, we could rewrite this fraction on the left as 1 over x plus 2 times x minus 2. Does anyone need me to explain how we could rewrite this denominator like this? I'll explain it now, unless you don't need me to. We're good? All right. So we have 1 over x plus 2, x minus 2, plus 6 over x plus 2. So now we could see what Christina was saying. We could multiply the right side by x minus 2. If we multiply the right side by x minus 2, the denominator on the bottom is going to be x plus 2, x minus 2. So if we multiply this by x minus 2 over x minus 2, the same way we did over here in the do now, we multiplied this by 2 over 2 to achieve a goal of a common denominator of 8. The principles are exactly the same. We're just dealing with expressions that are more than one term. The left side now becomes, so the right side will remain 1 over x plus 2, x minus 2. The right side is going to become 6 times x minus 2. 6 times x minus 2, which is 6x minus 12. Yes? 6x minus 12 over x plus 2 times x minus 2. Does anyone need me to explain anything before we continue? Brian, do we have the same denominator now?
Yes.
So if the denominators are the same, what do we do with the numerators? Let's add the numerators. The denominators are the same. So we just rewrite the denominator. We don't add the denominators. If the denominator is the same, we don't add them. We just write it. X plus 2. X minus 2 is the common denominator. And we'll just add the numerator. 1 plus 6x minus 12. 1 plus 6x minus 12. Combined like terms. This is 6x minus 11 over x plus 2, x minus 2. That is the sum of these two original fractions. Number 3. You don't need that one there. What's the goal when we add and subtract fractions? Do we have common denominators? If we get stuck, what should we try to do? Exactly. Can we factor one or both of these denominators? Which one? We can't factor that one. Yeah. Which one? Yeah. Yeah. You can multiply the one on the right to get this here. So if you could see it like Spencer did, perfect. If you didn't see it, so Spencer, you'd be fine. You'll get it a lot quicker. If you didn't see that you had to multiply top and bottom by 3, if you factored the denominator on the left side, the GCF is 3, and you're left with m plus 2. So if you get stuck, Spencer, you didn't get stuck. You knew what to do. But if you do get stuck, factor this denominator. And now that this is factored, you could easily see that they have an m plus 2 in common. The only thing missing here is that we need to multiply by 3. So if we multiply this by 3, we'll get 12m over 3 times m plus 2. So again, try to factor if you get stuck. If you don't get stuck, just keep it moving like Spencer did. Do we have a common denominator now? Angelina? Yeah, you could. Yeah, you could. That's if, Do it that way, because you're not getting stuck. So do it that way. But if you do get stuck, then just try to factor and see what's missing from the other denominator. But if you could look at this and say, I know I need to just multiply this by 3 to get 3m plus 6, then you could skip some steps and just do it that way. All right, now that the denominators are the same, you could just do m minus 12m in your numerator, and your denominator is 3m plus 2 or 3m plus 6. Both are correct. Combine like terms in the numerator. This is a negative 11m over 3m plus 2. This is fine, or you could write 3m plus 6. Either one is fine.